This is part 2 of my presentation on analyzing more complex motion plots. The motion analysis in this video will be a little trickier because I will mix D versus T plots with V versus T plots. Let's review again what uniform acceleration means. The velocity in both data tables change, but only the left one shows uniform acceleration. The acceleration is uniform or constant because the velocity increases by the same amount each time. This data shows uniform acceleration because every second the velocity changes by the same amount, 2 meters per second. Since the object increases its velocity by 2 meters per second each second, its acceleration is positive 2 meters per second squared. There is a two-step method that will help you analyze the motion that is produced in this plot and all other plots. The first step is called the y-axis analysis, and it involves looking at what is happening to the variable on the y-axis. The y-axis variable is velocity, and we see that the velocity starts at 0 and increases the entire time. Since the velocity is positive and increasing, we know the object has a positive acceleration. The second step in analyzing this plot is to look at the slope. Since this is a V versus T plot, the slope will tell us something about the object's acceleration. This is because the slope equals delta V over delta T. Since the slope starts out flat and gets steeper, we know that the slope increases. If the slope equals the acceleration, this means the acceleration is not constant but increasing. Now let's look at another plot. This plot looks like the last plot, but only if you don't realize that displacement is on the vertical axis. This changes everything. Let's start with step 1, the y-axis analysis. The displacement starts at 0 and increases the entire time. The object ends up a little over 5 meters from its starting position. Step 2 is to look at the slope. Since the slope is equal to the velocity and the slope increases the entire time, we know that the velocity increases the entire time. So now, is this constant acceleration or non-constant acceleration? Is the velocity increasing by an equal amount each time or a non-equal amount each time? Since the velocity is increasing in a smooth way, this plot shows constant positive acceleration. Memorize this one. The y-axis analysis of this plot tells us that the objects starting with a displacement of 0 and move further and further away from the starting point the entire time. The velocity is increasing most of the time because the increase in velocity is not smooth. This is non-uniform positive acceleration. Step 1 to analyzing this plot is to do the y-axis analysis. The displacement increases the entire time, so the object moves further and further from its starting point of 0. It ends up a little over 5 meters from its starting point. Now let's do the slope analysis. The slope of the D versus T plot tells us about the velocity. Since the slope is decreasing smoothly, the velocity of this object decreases smoothly. A smooth decrease in velocity means the acceleration is constant and negative. The y-axis analysis tells us that the displacement of the object started at 3 meters from its starting point and remained there the entire time. Since the slope is 0, this means that the velocity is 0 the entire time. Let's rank the accelerations found in this plot. Positions on the y-axis, and that is the same as displacement. We need to use the slope to rank these accelerations. The acceleration is the rate at which velocity changes. The only place that the velocity changes is between 0 and 3. All other times the velocity doesn't even change, because between 3 and 6 the velocity is 0, and between 6 and 9 the velocity is constant and negative. Watch the velocity in a speedometer move. Is it constant or non-constant acceleration? Because the velocity decreases smoothly, it shows constant negative acceleration. The y-axis analysis on this plot tells us that the displacement starts at 0 and increases to over 20 meters. The slope analysis tells us that the velocity is constant. If the velocity is constant, this means the acceleration must be 0. If you don't look at this plot closely, you might think that it was identical to the previous one. What makes it different is the variable in the y-axis. Let's use our two-step plot analysis. The y-analysis of this plot tells us that the velocity starts at 0 and increases to over 45 meters per second. The slope of this plot is equal to the change in velocity divided by the change in time, which of course is acceleration. Since the slope is constant and positive, this tells us that the acceleration is constant and positive. The y-axis analysis tells us that the velocity starts at 55 meters per second and ends up at 0. Since the slope is the acceleration, we see the acceleration is constant and negative. In this presentation, you learned that you can interpret the motion of a plot by looking at y-axis changes and the slope. You learned that when a d versus t plot has a smoothly increasing or decreasing slope, it shows a constant acceleration. When a velocity versus time plot has a constant slope, it also shows constant acceleration. This is the end of my presentation on interpreting complex motion plots.